This is on the cumulative AP test. I'm going to go through some of the questions, and if these are things that you need to study. The first questions are going to talk about is a distribution skewed to the left, skewed right, or roughly symmetric. So remember, if it has outliers that are far out to the right, that are way positive or way more than others, then that would make it skewed right. If it has outliers that are way less than others, that would make it skewed left. And then if it doesn't really have any outliers, then that would make it roughly symmetric. So that's what you're looking for there. Remember, the mean gets pulled with the outliers. So the mean gets pulled in the direction of the outliers. Again, for a z-score, remember a z-score is x minus the mean divided by the standard deviation. So that's how you get a z-score. 90th percentile, 80th percentile. If you want to look at percentiles, remember you can look in your table of z-scores and look for 0.9 in the middle and see what z-score that goes with. You should also know how many standard deviations away there are, how to draw the normal curve: 34%, 13.5%, 2.35%, and then 0.15%. So everything about the normal curve you should know. Now, if you double something, or if you multiply something, what it will do is it will increase your standard deviation. So let's say, if you double a number, it will also double your standard deviation. But then if you take all those numbers and subtract from them, like for instance, let's say I subtract 10 from all those numbers, it will take my mean or my average down by 10, but it will not change my standard deviation. Because if I subtract every number by 10, I'm still going to deviate the same amount. So when you double something, then yes, it doubles your standard deviation. But when you add or subtract all of them, it does not, because you're adding or subtracting them all by the same number. So mean is affected by that, standard deviation is not. Okay, next one. If you're blocking something by male or female, then what you're doing is you're making sure you have an equal number of males and equal number of females. And if you have like 3 treatments, then you've got to make sure in each treatment you have females and males. So they can't be a treatment where there's all females or all males. That's blocking. When you're looking at a prediction equation, make sure you understand the question on here is going to be like, which of the following is not correct. So make sure you understand what a prediction equation tells you. And when you plug that number in for x, what is it saying? When you plug the number in for x, you're predicting for the y, but what is it saying? That the y is going to go up by how much each time, or that each time you put in the x? Okay, so we'll go through that. Make sure you know what a residual is in a prediction equation. So if I put a number in and get a prediction that's less than, or I get a prediction and then what actually happened is less than the prediction, then I should have a negative residual. If what actually happened is more than the prediction, then I'll have a positive residual. Remember, residual is just observed minus predicted. A normal curve, you should be able to look at a normal curve and tell what the mean of that normal curve is. The mean would just be right in the middle of it. And then a standard deviation, if you look at a normal curve, each one you should be able to go 3 standard deviations to the right and 3 standard deviations to the left and be right at the tail of those curves. So you should be able to tell the standard deviations as well. So basically, can you draw on a normal curve the mean and the standard deviations? Also, if you look at a set of data, you should be able to tell if it is if there's something, if it's negative association, positive association, no association, if it's linear or not. Also, you should be able to do a 5-number summary, box plots. Remember, you put all those in L1, and you can do stat calc 1 variable stats. Will give you a 5-number summary if you just have one set of data. And you can do box plots. The IQR, you should know how to get that, Q3 minus Q1. And again, stat calc 1 variable stats will give you that, so if you need to do those. You should also be able to tell the difference with an explanatory variable and a response variable, the correlation between those. You should be able to kind of draw a graph to tell if there's a positive or negative correlation to support your results. And then we talk about the different samples. A simple random sample means you just take a sample straight from the population. It's just a simple, but it's random. A systematic random sample means you got to develop a system. It's more complex. It's tougher to do. A cluster sample is what we talked about actually on the test. A cluster sample is where you actually take the population, which was the whole forest, and they divided the forest into plots, still using the whole forest, and then just picked from those. Stratified random sample is when you're talking about groups. So when you group something, when you see the word group and they're separated into groups, you're talking about stratified. Strata means groups. And then a voluntary response means that they had to volunteer for it, and that's your worst type of sample. Now if you're going to look at, let's see, this says if you're planning an experiment, you should be able to tell how to plan an experiment. You should also be able to find residuals if I give you points. So if I gave you like 5 points, the X and the Y, you should be able to put the X's in L1, put the Y's in L2, and can you find the residuals? Remember, that would be L2 minus Y1 parentheses L1. But if you haven't already done stat calc 8 and saved it in Y1, then you won't be able to do the residuals. So L2 minus Y1 parentheses L1, but make sure your equation would already have been saved in Y1. Then mean and median. If you have a frequency table, so if you have a frequency table which tells you how many times something occurs, you can find the median by just finding the middle number. You can find the mean by seeing if it's skewed left or skewed right. If it was skewed right, the mean would be a little more. If it's skewed left, the mean would be a little less. If you're looking at 2 box plots, you should be able to compare the 2 box plots and tell what the difference is between the two. And then we get to some of your free response problems. On the free response problems, the first one, you're going to be looking at a stem and leaf plot or a stem plot, and you're just going to be telling the differences. You're going to have to write some sentences about the distribution. When you're writing about the distribution, you're writing about shape, center, spread, and outlier. So it's SOX. Remember, shape, outlier, center, spread should be the things you're talking about. Which machine should be chosen? So basically, you want to explain which is the better choice. It's going to be a back-to-back stem plot. You're going to have one machine here, one machine here. You're going to tell which one's the best, and then give a reason why the experiment is not as good. So you're basically going to have to give some conclusions about ways that experiments aren't the best and ways they could make them better. As we get to the next problem, random digits table. Don't forget, if you have, so I'll give you a hint in this one, you have 60 things. If you have 60 things, then you're going to number them from 01 to 60, and you're going to look for the first ones that appear, and you need to, again, explain your system and how you're going to do that. So if I have like 10 people in my sample, I'd number them 0 to 9. The first 5 that appear would go in one group, and the other 5 would go in the other group, kind of similar to that. And then the last question, if you look at a computer printout of a linear equation, you should be able to give me the equation. The coefficients, the one beside the word is your x value, or is your slope. The one beside which in this problem would be shelf length, and then the one beside constant is the number by itself, so it's your y-intercept. So you should be able to tell the equation from there. Interpret the value of S. S is your standard deviation. Your standard deviation is how far on average your predicted values are from your observed values. So that's your standard deviation, how far on average what was predicted is from what was observed. So how far on average do they vary one way or the other. And then the coefficient of determination, I don't know if we've said that, but that's R squared. So R is correlation, R squared is coefficient of determination. And remember, R squared also tells you the percent of the data that's explained by the line. And then, again, how do you explain the y-intercept? So is the y-intercept included in our data, or is it too far away for it to make sense? And if it is too far away for it to make sense, what do we call that when we try to predict something that's too far away from the rest of our data? So that really takes you through the cumulative test. I don't think it's extremely difficult, but it is something that you have to go back and think of and remember chapters before. And we'll do this again. We'll have 3 of these in total, where you have to go back and think of previous chapters and add it all together. And these are the things that you'll need for the AP exam and getting college credit. So don't miss the big picture. The big picture of this is, can I get college credit, and can I pass the exam and be successful, and you know, and we'll be proud of you and everything. So think through that, and we'll see you later.